Hello friends, my name is Siddharth Dagar and I welcome you all to the YouTube channel of Prayas IAS. We frequently bring new topics, new issues which are in news and which are very relevant from the perspective of your exam. Our aim is not just to cover that particular issue but various concepts which surround that particular topic. And this is the right strategy for your exam. As we see the changing pattern of civil services, they are not just focusing on the current news, but they are focusing on various topics which are interrelated with that particular issue or current affair. Today's topic, which you must have heard recently, the name of the topic is artificial sun. Recently, Korea, or to be specific, South Korea has brought out or developed a new fusion reactor, and they have created a world record of achievement of 100 million degrees Celsius worth of temperature for a time period of 48 seconds. I know you are not able to understand anything right now because the basic concepts, basic logic behind this topic is not clear. I assure you, by the end of this video, you'll be able to understand this topic in a holistic manner. First look at the current affair which was in news. Kstar, or the Korean artificial sun. As I told you, they have achieved temperatures worth of 100 million degrees Celsius, and the time period or the world record is 48 seconds. To understand this particular topic, we need to cover certain basics. These are the basics that we need to cover before understanding that particular current affair. First, we need to understand what nuclear energy is. Then, the type of nuclear reactions. Third thing, we will jump onto the artificial sun topic. And there's one more important term in news, which is called Tokamak. Finally, we will see if there is any international program running with respect to this topic. And at last, obviously, the topic of the video. In our junior classes, all of us have seen the structure of an atom. I hope you have seen the structure of an atom. In between, we have nucleus. Nucleus is made up of protons and neutrons. And surrounding this nucleus, there are large number of electrons which are orbiting around it. This nucleus basically is a source of energy for us. And when energy is released from the nucleus of an unstable atom, it is called nuclear energy. How this energy is released? It is released because of two nuclear reactions. First one is nuclear fission, and the second one is called the nuclear fusion reaction. As the name suggests, nuclear fission. What is the meaning of fission? Fission means splitting. When there is an unstable nucleus, and that unstable nucleus splits into two parts, to two small nuclei, and in that reaction it attains stability. This is called nuclear fission reaction. Let us take one example here. You can see uranium-235. Uranium-235 is unstable. This is the fuel which is used in nuclear fission reactors. This uranium-235, during the course of fission reaction, it breaks into two lighter elements. It breaks into first barium, and second it breaks into krypton. Now both of these are stable. Uranium, which was unstable, is now broken up into two stable nuclei, and in the course of this reaction large amount of energy is released. This is what is called nuclear energy. Second type of nuclear reaction is called nuclear fusion reaction. This is nothing but the opposite of nuclear fission. Fusion means combination. When we combine two lighter nucleus which are unstable, and with the help of that combination this particular reaction achieves stability. One example is the reaction which is taking place right now, continuously, 24/7 on the surface of the sun, which is the source of energy for all of our stars. That reaction is called nuclear fusion reaction. Tritium, one isotope of hydrogen, and deuterium, another isotope of hydrogen. When both of these combine, when both of these fuse with each other, the final product is helium, and with that final product a large amount of energy is released. This is called nuclear fusion energy. Is the reason behind release of this energy from both of the reactions, fission as well as fusion. You must have heard about a very famous scientist and the formula which he gave to us, Einstein, and a very famous formula called energy mass equivalence formula, E is equals to mc square. In this particular formula, E is energy, M is mass, and C is the speed of light. What does this formula tells us? According to energy mass equivalence formula, energy can be converted into mass and mass can be converted into energy. Now if we look at the reactions, both fission and fusion reaction, which we just saw previously, in both of these reactions, the final product which we were getting, the final product, mass of that particular product was less than the mass of the reactant. Mass of barium plus krypton and other things in that reaction is less than mass of the initial reactant or uranium. In the fusion as well, same thing. The mass of the product is less than the mass of the reactants. Now where did this mass go? This is the mass which got converted into energy. And this energy is released in the form of nuclear energy that we saw in the previous reactions. After understanding this concept of nuclear energy, now we can compare both fission reaction and fusion reaction. When we compare both fission and fusion, we see that fusion reaction has certain comparative benefits. Certain comparative benefits when we compare it with nuclear fission reaction. One very important benefit is that the energy which is released during nuclear fission reaction is very, very high compared to nuclear fission reaction. That means if we take up equal amount of fusion fuel and fuel for the fission reaction, and energy is released in both the reactions, that energy which is released in fusion reaction will be much higher compared to the fission reaction. Second important benefit of fusion over fission, the raw materials which are used. The raw materials which are used in nuclear fusion reaction, they are first cheaper, second they are available in abundance. On the other hand, if we see the fission reaction, in fission we use fuels like uranium, plutonium, and these fuels are not available on the surface of the earth in abundance. For example, we have to import uranium from outside in India to run our fission reactors. Third important benefit of fusion over fission is the nuclear waste. In fission reaction, in fission reactors, there is a large amount of nuclear waste which is released. And this nuclear waste becomes an issue if it is not managed properly. On the other hand, if we see the fusion reaction, there is no nuclear waste. Thus, we can say it is a much better and cleaner form of energy compared to fission. Because of these benefits of fusion reaction over fission reaction, our scientists are trying to harness the fusion energy. That means they are trying to replicate or copy the reaction which is taking place on the sun. And when we try to replicate that energy, that reaction on Earth, we call that reactor as artificial sun. Simple. The name is very fancy, but the concept is simple. We are trying to replicate the energy production process, that is the fusion reaction on Earth. This is called artificial sun. The benefits of nuclear fusion reaction, still we are not able to replicate those reactions on Earth. The reason behind this are some issues with respect to the fusion reaction. Now see, what is the concept? For fusion reaction to take place, let us take the example of deuterium and tritium. When we will try to fuse both of these atoms or nucleus together, because of these electrons which are revolving outside the nucleus, there will be a repulsion. A repulsive force will be created, and this repulsive force will make the fusion reaction very, very difficult. This reaction takes place on the sun because of two very important conditions which are present there. First thing is high gravitational pull which is present on sun. The sun's gravity is maybe 27 to 28 times the gravity of the earth. And second very important thing or condition which is present on the sun is the high temperature. The temperature of the core of the sun can reach up to 15 million degrees Celsius. Imagine. And because of these two conditions, this repulsive force of the electrons which are becoming an issue for the fusion, this is compensated because of these two conditions. This is the reason why fusion reaction takes place on this. This is why the fusion reaction takes place on sun. Now, if we have to replicate the fusion reaction on Earth, we need to replicate both of these conditions. But once again, there's an issue. This first condition is not possible on the surface of the Earth. Then what to do? We need to compensate this condition as well with the help of high temperatures. Not just 15 million degrees Celsius. For the fusion reaction to take place on the Earth, we require temperatures of up to 100 million degrees Celsius. Now it becomes a challenge. First, to reach up to that temperature, and second, to maintain that high temperatures for a longer period of time. How our scientists are trying to achieve this? Let us see. The challenges which I just told you is first to reach up to 100 million degrees Celsius, and second is to maintain it. First we have to reach up to 100 million degrees Celsius so that fusion reaction can take place, and second thing is to maintain it for a longer period of time. To reach up to this temperature, scientists use something called as plasma. Plasma is nothing but the fourth state of matter. We know that there are 5 states of matter. Plasma is the fourth state of matter. First one is solid. Second is liquid. Third is gas. Fourth is plasma. When we add heat to solid, it becomes liquid. When we add heat to liquid or increase the temperature of a liquid, it becomes gas. And if we increase the temperature of a gas or add heat to it, it becomes an ionized gas. This ionized gas, which is at very, very high temperatures, is nothing but plasma. So one thing is clear, that plasma have a very high heat carrying capacity, and thus plasma can be used to reach up to the temperatures which we were just talking about, 100 million degrees Celsius. So the first challenge, to reach up to that temperature, that is resolved with the help of usage of plasma. Now what about this second challenge? To maintain this temperature, scientists have developed a nuclear fusion device or nuclear fusion reactor, which is called as the Tokamak. Very unusual name, Tokamak. Tokamak is a Russian word because this prototype, this device was created by the Russians. And Tokamak in Russian means the shape of torus, or we can say the shape of donut, or the food mendu vada which we eat. Vada or donut shape, which is called Tokamak. Now how this reactor, how this Tokamak shape is used by the scientist to maintain very, very high temperatures. Let us see this shape first. The shape is a donut shaped. Now the second thing, outside this reactor, outside this donut shape, we have superconducting magnets. These superconducting magnets surrounding this nuclear reactor, basically they are creating a magnetic field. This magnetic field acts as a shield for the plasma which is there inside. Plasma was used to reach up to high temperatures so that fusion reaction can take place. But the issue was to maintain such high temperature. And the next issue is to confine that plasma so that accident do not take place or leakage do not take place. So the second challenge of confinement, second challenge of maintenance of the temperature is overcome by this shape as well as the superconducting magnets. This magnetic field allows the plasma to remain inside and have a temperature of 100 million degrees Celsius. This reactor, fusion reactor, is called as Tokamak. Now what is happening at the international level? Many countries are coming together and they are trying to build the largest Tokamak or nuclear reactor in the world. This program is called the International Thermonuclear Experimental Reactor. This ITER is being developed in France, and more than 35 countries are coming together and trying to build this ITER. One very important fact with respect to the exam, India is also a part of this ITER, and we are contributing a lot to the ITER program so that in future nuclear fusion reaction can be utilized for generating commercial level electricity, which will be a huge boost for our own economy and for humankind as well. Now, after all of these topics, after all of these concepts, I hope now you will be able to understand the current issue which was in news, or the current affair which was in news. Korea have developed an artificial sun which is called Kstar. It is nothing but a Tokamak. It is nothing but a artificial sun. And they have been able to achieve 100 million degrees Celsius, the temperature which is required for nuclear fusion. And they have been able to achieve it for the time period of 48 seconds. Now this 48 seconds is a world record. Scientists are trying slowly and slowly to increase the time period of this nuclear fusion reaction. When we will be able to achieve this temperature for longer period of time, then only this nuclear fusion energy will be beneficial for us. it can be utilized at the commercial level. So I hope after all of this topic is very, very clear to you. We will continuously try to bring new topics which are relevant from the exam perspective. To stay connected, please subscribe to our channel. Keep studying, keep working hard. Until next time, Jai Hind.